Good afternoon. Thank you to the OpenNebula guys to allow us to share with you what is our approach or vision or how to create and optimize the deployment and the management and, well, in fact, the full life cycle of infrastructure services. I think that during all the day we have seen services on top of cloud, and we are going to focus in infrastructure services that are always inside the services that we are using in a cloud. Okay. Well, first of all, let me introduce. My name is Xavier González. Here is my contact information, and well, here is we can see the knowledge and experience tag where I have been focusing during the last 20 years. That is the time that I am working in IT. And I am the CTO and co-founder of Viapps. That Viapps is a solution that runs on top of OpenNebula in this case. Well, very quickly, something that we have been repeating during the whole day. For me, the best thing that the cloud is providing is elasticity. I don't know if, probably because I come from the technical part, and it is something very surprising that you can adapt your infrastructure or your capacity depending on your demand. I don't know, 10, 15 years ago with the .com area, I remember that we need to suffer and the effort that we need to do if we want to increase capacity in our services. We need to put more hardware, we need to install it, we need to configure a lot of things. For me, elasticity and, of course, instant capacity, time to market are the best things that cloud are providing. But, of course, nothing is free. First of all is our applications need to be cloud aware. Okay. It means that not all the applications are ready to be run on top of a cloud, or at least to get all the benefits that the cloud provides. Another thing that is important not to forget is portals, e-commerce, intranets are always using load balance, firewalls, DNS, DHCP servers, always. Most of the cases, okay, not always. HTTP proxies, SMTP relays are always services that are repeating in a lot of biggest services like portals and so on. Of course, if we are talking about cloud, there are a lot of architecture considerations that we need to take care, and the presentation that we had before the lunch was a very good example of disaster recovery and things like security, where to store the information. If it is a private cloud, then you can manage where the information are stored. And another thing that is important not to forget is normally open source is a way that, or is a way to do things that fits very well in this ecosystem. Okay, and this is something important. And okay, if we focus on infrastructure services that are important because they are using always in a lot of services on top of the cloud, okay, how can we deploy that infrastructure? We can do we can name the traditional way to do things. That is, okay, I need more capacity, I get or I need a load balance, I get a external appliance or hardware appliance, I configure, I put in the network, and that's all. Or if I need a firewall, something like that. It's a good approach, but it is not very cloud aware. I mean, it's, if you are going to a 100% cloud system, probably is not the best approach to do that. You can install VMs from the scratch with open source or commercial software, and well, you can do it, and you can put the service on top of a VM and can works, or you can use virtual appliances, I don't know, for example, like pfSense or many other Linux distributions that are optimized to do this kind of services. And normally these solutions are very focused to a fast deployment, but they are not taking care about the rest of the tasks that we need in order to support the full life cycle. Okay, probably there is some mixes that you can do with that options, but let's see what are our approach. For me, okay, once we have summarized a little bit what is the situation and the importance to take care about infrastructure services, okay, how can we speed up deployments and maintenance of cloud services? It is clear that if we speed up our infrastructure services, we are speeding and we are helping to speed cloud services in general. Okay, what are, we can name a set of requirements that probably are important to take care about that. Some key requirements is not to take care only about a fast deployment, is what happens with the rest of the process in the life cycle, update, maintenance, administration, and so on. It is clear that infrastructure services are repeating in a lot of services. Why don't use templating services? I mean, it's something that I do the integration once and I can repeat several times. Central management is always something very important to request, because I don't want different tools and different places to manage the services. Well, of course, powerful. I don't want a tool that only can do several basic actions with the front end, and I need to go to the configuration files to do the rest of the tasks. Easy to use. Well, tools are easy in the way that they are easy to manage for the different roles that needs to take care. But it is clear that if you try to provide wizards in order to create the most frequently task, is something that is positive for the end user. Based on API REST, I think that it is clear that in a cloud that is something that is composed by different components. If you have an API, a REST API, then you can integrate better in a biggest platform. And of course, open source, because I want to see the source code, I want to hack it, and I want to know how does it works internally. Our approach to do that, okay, let's to see how we get that requirements and that situation, and what is the way that we try to do with a cloud. Most of the customer has a cloud infrastructure, OpenNebula, with the different hypervisors that they are working, and that we put on top of that is a solution. In this case is Viapps. Okay, that solution, what it is a solution that allows to provide full life cycle for a set of infrastructure services. Okay, it is not a cloud solution. It is something that runs on top of that cloud solution. Okay, it is something that allows to us to manage our infrastructure services and deliver or deploy new infrastructure services and update and so on. And we will see now how does it works. Okay. Let's to see what are the main components that we have. In this case, we have a central management interface that is a VM that we deploy on top of, the cloud. That central management interface is a CentOS-based image with several standard components. For example, we are using Opscode Chef in order to automatize all the process to install and update servers. We have an RPM repository. We have a MySQL in order to save and maintain metadata. And we have our portal that is named CMI portal, and we have an API that orchestrates all the tasks that have to be done. And this central management interface allows to us to deploy that we name service nodes. Okay, these service nodes are based on CentOS 2, has an CMIX for Express API, CMIX portal in order to be administrated and managed. And for example, if we are talking about firewall, we have here as a service, we have two open source software, that is Shortwall and IP tables. Okay? In our case, that we have done is not to reinvent the wheel. I mean, it's firewalls. There are a lot of open source firewalls that are working very well. That we have done is to integrate in one image, put a layer here that allows to manage, that firewall. And for example, we are using webmin, not as a front end because, okay, it's a little bit ugly and raw front end. That we are using webmin is using the XML RPC gateway of webmin in order to manage all the configuration files of the server. We don't want to reinvent the wheel, I have said. For example, if we are talking about load balance, we are using the software IPVS for Linux virtual servers. If we are talking about DNS, DHCP, we are using Bind and ISC Daemon. Proxy, we are using Squid. Relay, we are using Postfix, for example. And the idea of that, and in the next slide we will see working, is that from here we can provide the full life cycle of any of these, servers. Okay. Let's to see a graphic trying to describe how does it work. Okay, we have the cloud, we have the administrator, and we have our first central management interface deployed, that is a virtual machine. And from here, the administrator can create and install new services, only has to do a wizard of 4 steps and a new server appears. We can integrate our CMI in order to notify to external CMDBs, for example, that a new service appears, because this is important if you are working in a very big corporation. Normally, they have external CMDBs. What else? We can create new instances only selecting the basic information of that instance. What is the management IP? What are the basic configuration that we want to push, and then appears that instance. And not only we are focused on the delivery, okay? We are focused in the management of that virtual machine, that service. If we are talking about, for example, DNS, DHCP, we can define new domains, we can define new registries for domains. For the DHCP, we can define new range, new exceptions, new fixed IPs for a specific MAC. We can manage most of the use case that has each of them from the central management interface. Okay. What is the idea? The idea is not provide only a tool that allows you to deploy fast. I think that there are a lot of tools that allow us to do that. Our idea is, if we have the central management interface, we have a service, we provide the install process, we provide the basic configuration process. I mean, is the first configuration in order to be up and running. We provide the advanced configuration. For example, if we are talking about the firewall, we provide how to manage all the firewall objects, networks, host, ports, NATs, whatever. Specifically with the firewall, that we do is we have a CMDB here that share all the firewall objects, that is networks, objects, default rules, for example, shares that information with all the firewalls that are deployed with that CMI. It means that you don't need to specify twice where is the FTP server. You define the object once, and then all the firewall nodes has that information. Of course, you can do that with IP tables and scripting. Of course, you can do it. The idea is that we do in a standard way to do that. Advanced configuration, updating, something very important. As soon as we release new versions of the firewall or of the CMI, we can manage the update of the service from the CMI. Management, of course, every day-by-day action that we need to do, generate new rules, apply new NATs, new masquerading, and so on. We can do it using the tool. We don't need to hack in a low level. CMI monitor the service, and we have trending information, for example, and performance. And we have audit that everything that is working, all the configuration files and the binary files are only managed by CMI, not from external sources. And this is a full life cycle. I mean, we repeat that process as many times as we need. Okay, let me show you some screenshots. Okay, the quality is not so good because the resolution is not so good. Here, that we have is the list of VMs deployed. For example, we have here, this is a DHCP. Okay, we have here the flavor, DHCP, firewall, HTTP, what is the version, what is the management, IP, and so on. From here, we can go to the trending and see what are the trending of a specific node. For example, if we are talking the firewall, we have here the parts that are in blue. This is objects that are in the CMDB, and when you are on top of that, you can see what is the real value. And here, for example, you have the rules of a specific firewall. Okay. In this case, we are managing the subnets of a DHCP server. And okay, we have seen a little bit how does it work, what is it, how we integrate that with OpenNebula. Okay, we have seen an agreement with OpenNebula in order to be partners, and that we have is basically two ways to do that. The idea is, depending on the tool that we want to be as the master, we will have two ways to integrate. We have the user, that is the system administrator. The system administrator has a server definition that is a set of parameters, the IP, the name, what is the size, what is the flavor that we want to deploy, what is the network information that we have, and what is the bootstrap commands that we want to send. I mean, if we are deploying a new DNS, we want to set up domains and entries for that domains. We can put here all the commands. And that we do is the user send all that information to OpenNebula, and then OpenNebula, that it does is create the VM, create all the network VLANs that are needed for that specific node, copy the base image of Viapps, that is a CentOS, is 100 megabytes of image of CentOS, a very basic image of CentOS, set the management IP and boot. And at that time, OpenNebula will call to CMI API with the same call, basically, at server with all that information, in this case, this information. And what we do here is we create internally our Viapp. We add all the security stuff, basically some keys to the server, and starts the installation. How do we start the installation? We run the Chef client. I mean, I repeat, we don't want to reinvent the wheel. Chef is a very good software in order to send receive to the servers and do installations, and we are using. Install the server, of course. Once it is installed, then we set the bootstrap commands, config the server, and once it is configured, we answer to the user that it is up and running, and then the user can start to administrate. Okay? Second part of the integration, on another way to integrate the software, will be something similar, but let me go to the end because it's very similar and I will explain the main difference. Is user is not talking directly with OpenNebula, is talking directly with our CMI. Then we call from CMI the add server to OpenNebula, and we do the rest of the task that we have explained in the previous slide. Okay, these two options is something that, well, let me show you timing. We have defined this integration, well, in the previous weeks. We are starting to develop the integration now, in fact, during the last quarter of this year. And we want to have a beta available at the end of the year, and in the first quarter of next year, we want to have a general available integration of both. Okay. And from my side, that's all. Okay. Questions?
I have a couple of questions. One, is it possible to install CMI and on top of the very same virtual machine firewall, for example?
No, no. You need to each flavor. Well, the question was if it is possible to install CMI and some node in the same VM. Question is, answer is no. We need to have a specific VM for CMI, that is only CMI, okay? But it is a VM, okay? We don't need to be bare metal, something like that. And then we cannot mix flavors. I cannot have the same VM acting as firewall and proxy at the same time. At least at this moment, we believe that it's cleaner to do in that way. And cloud, I think that is one of the advantages that it has, that it is not so difficult to create new instances. Okay? But
the other one is that you show that you have a web interface in the CMI to manage the nodes, and another web interface inside every
yeah.
Can you manage everything from the CMI?
Yeah, the normal way to work is you manage the CMI, and from the CMI you manage the rest of the nodes. But one requirement that we had from the beginning is, okay, we don't want to depend, we don't have to have the depend of the CMI. I mean, if CMI goes down by any reason, I want to manage each node directly from the management interface, and you can do it. Of course, you don't have, for example, single sign-on and things like that. If you go directly, you only have emergency password to the node, but you can do it. Because in fact, the management, when I set, for example, a new domain to a DNS, it is set in the node, not in the CMI. CMI that is doing, for example, is doing backup of the configurations each time that we program. But CMI does not know how many domains has that specific node, because everything is in the configuration files of the node. And we are not using any intermediate database in order to save the configuration. We are using always the configuration files. For example, if we are talking about DNS, we are using the bind files in order to store the configuration. Okay? More questions?
I have a question about scalability.
Yeah?
At how many appliances do you start to have problems on the CMI?
Okay, good question. We have been testing with 50 nodes for CMI, okay? And, well, in fact, the work that the CMI is doing right now is collecting logs, okay? If you deploy 100 nodes and start to work each firewall, each DNS, each proxy, and so on, the only work that is doing CMI is collecting logs. It means that depending on how much logs are providing the nodes, more scalability, bigger or smaller, should be my CMI. But my advice is, okay, normally put 50, not much more, because, I mean, if you can deploy several CMIs, okay, and you can manage better if you do it in that way. But, okay, you can grow. If you put more resources to the CMI, you can grow to more nodes if you want. Okay?
Question?
Yeah, sure.
The CMIX part for connected for talking to the actual appliances,
Yeah.
is that in a way modular? Can I write my own appliances?
Yes, 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 very, very good question. We have defined a way to do CMI API, the CMI Express API. We have defined a way how to manage that way. For example, everything is deployed in RPMs. If we want to deploy in our own CentOS or Red Hat OS, and we have defined a way how to do it, okay? And if you want to write your own flavor, this is something that if you go to viapps.org, there you can reach our Redmine, that is redmine.viapps.org. And we have specified there what is our REST API and the way that we are doing in order to publish new services in the node. For example, imagine that you want to do, a filer flavor, for example. That is a flavor that some customer had request to us. And you define there, for example, how to create a new file resource or a new share, new users, and so on. Then you need to publish that in the API, in the Themix API part, and then create the portal part of that API in order to manage from the website. There is a way to do it. In fact, there are 5 flavors already implemented that acts as example how to do it. And I think that is something that is very mature at this point. Okay? That is not difficult to see that we are providing the full life cycle of the services that are very specific. We are not general purpose full life cycle tool. That we do is for 5 specific flavors or needs, we are providing the full life cycle. I mean, we are providing everything that you need in order to work with them. If we want to expand that, we have roadmap in order to expand that flavors. Okay, we are open, and in fact, it's something that we want to improve. Okay. What else? More questions? In the next few weeks, all the code and live VMs will be available. They are not available right now because we are cleaning some part of the code, okay? And well, the only I can say is stay tuned, visit viapps.org, and you can see all the functionalities. And we are working in order to be fully integrated inside OpenNebula. In fact, I suppose that next steps will be to be in the market of OpenNebula in order to deploy a CMI directly from the market of OpenNebula. Okay? Thank you. And